Hello, so welcome to the next in the Tank Storage Magazine Tank Talk webinar series. Today I'm joined by two leading industry experts from Varec, Derek Blagg and Adam Wishel, who are going to talk us through how to connect the dots and maximize your system through smart engineering. Before we get started, a few housekeeping points. Please do participate in the polls. You'll see them on the right-hand side of your screen. The presentation will be followed by a Q&A, so feel free to type in your questions into the question box, and the presentation will be made available to you afterwards. So our speakers today have nearly 50 years of experience between them. Derek's been in his role for 23 years and currently oversees the product management and marketing for Varec. And Adam is currently a regional sales manager, and he's currently leading Varec's expansion into new markets. So Derek, over to you.
Thank you, Margaret. Appreciate the introduction. So just a little bit about Varec, the company that Adam and I have worked for quite a number of years, as you just saw. We are a wholly owned subsidiary of Leidos, a larger corporation. Primarily, their work is in the areas that you see there on the right-hand side of the screen in the civil, defense, intelligence, and health industries. At about $12.3 billion, they've got about 43,000 employees. Varec is just a little bit smaller than that. We're about 160 employees. We're located just outside of Atlanta, Georgia, in the U.S. And we focus primarily on the oil and gas, defense, and aviation markets for fuel farm management. So we're going to talk a little bit today about some of the experiences that we've had, some of the learning that we've gone through, some of the challenges when looking at automating and moving forward in those industries. And so we're going to talk about connecting the dots between the different areas within the operation, how you get to where you need when you're looking at automating a system. So this is kind of a general landscape of what we might see out in the field. Some of these pieces may apply to your operation, some maybe not, or maybe you have a load rack in some locations or not in others. But what we see at a lot of locations that we work with and customers we work with is they're dealing with legacy systems and devices. Maybe some of those are obsolete or end of life, and they're looking to update those. They're trying to scale the legacy systems to meet changing needs of the business. Things are changing, and they want to make sure that they can keep up to date with those. Maybe some of the new devices that are being purchased or brought in don't support some of the other legacy devices that are there, or maybe some older field protocols. And then maybe some of the legacy devices are isolated and they're not able to get information out of those into business systems. And then managing the individual components, the devices, the interfaces from all the different manufacturers, having to make phone calls for support to different groups. How do you think about, maybe looking for one group or fewer groups to provide those solutions? So we'll talk a little bit about that today. Managing the communications between those systems, both from a physical and an infrastructure standpoint. We're going to talk a little bit about that today as well. And then understanding the implications, maybe safety implications. There may be an update in technology or processes due to the new systems or the changing systems. We'll talk a little bit about that through the process today. We'll also talk about shifting from cloud and the cybersecurity requirements that we have today in these facilities. More and more people want to take data from the local sites and get that up to maybe an enterprise system, maybe some of those systems being installed in the cloud rather than being installed on site. Knowing how to get the most out of those components and that system on site there as well. And then we'll talk a little bit about optimizing operations, maybe during manned or unmanned periods. We'll talk about things that you need to think about in those cases. And then just in general, deploying the right automation for completely remote and unmanned sites. And so the goal of today is to talk a little bit about how do we connect the dots between all of those pieces out in the field, back to your control room, back in the office, and to the enterprise. And with that, I'm going to turn it over to Adam to start talking about some of the details, some of the things that you want to think about more specific and as we go through each one of these areas. Adam? Adam, I think you're on mute.
My apologies. Thank you, Derek. Connecting the dots involves both thinking of the bigger overall picture as well as the individual components or each dot, if you will. It's kind of a forest in the trees mentality, right? So the overall goals or desires of the company or the enterprise at the enterprise or the corporate level is the overall picture or the forest, if you will. But each dot in this equation or each tree of the forest has a role to play and can impact that overall picture. So it's very important to have the overall picture or forest in mind when you're working on each of the trees. Sometimes you have to have different people working on the individual dots, and so a different person focused on the overall picture, and they need to check and balance and work with each other in order to get to the end goal. That's just an overriding theme of the entire thing. So in the end, the forest or the overall picture is going to have to be flexible anytime you're making changes, because the capabilities or limits of devices on each of these dots will impact the overall capability of the system. And to get started, we're going to start at the tank and move towards time. What people first consider is just accuracy. How much accuracy do we want? In reality, so accuracy is a one-time measurement of the device accuracy versus the true level. Repeatability, however, is continued accuracy over a duration of time. So repeatability, accuracy is I'm within this much of the real level. Repeatability is, okay, I'm within this much of the real level, and then if I take a volume out and put that same volume back in, do I still have the same, does my device still report the same level relative to the real level? And repeatability is really what you want. And different devices have different capabilities with respect to repeatability. So how tolerant, and one of the main factors with deciding what type of gauging system you need is how tolerant that gauging technology is to the environment where it's installed. Radars, servo gauges, magnetostrictive gauges, a lot of technologies are mounted to the top of the tank and are installed in the shell and are open to the environment inside the vessel. Some materials may include vapor clouds that may coat or varnish the interior of the vessel over time. And how will that react to the device technology? So will it coat the inside of a radar horn and mess with the accuracy of the signal? Will it gum up the interior of a servo gauge? Things like that are things that you need to consider. And then what are you measuring in general? Do you want to measure solids? Is it a liquid? Are you measuring a gas or a combination of all the above? And then how do you measure it? Are you measuring in terms of just volume measured in and out of the vessel? Are you measuring the liquid? Are you measuring the level of the liquid itself? Or are you just measuring the weight of the product? Do you need to capture temperature or pressure? Do you need to compute density of the product? A lot of these questions will get answered based on the overall goals for the overall picture. But they all need to be considered at this level as well. And then, of course, how do you communicate with the devices on the tank? Do you have high-level switches that just provide you with yes or no, true, false? I have a high level or I don't. Do you have level gauges that give you a precise level, from the bottom to the top of the tank? How often do you get updates from those devices? Do you get updates once an hour, once a day, every few seconds? So if you get an update every few seconds, could you calculate the rate of change in the tank, how fast it's filling or emptying? Could you calculate that into a flow rate? How useful are those things at the enterprise or corporate level? And then you got to get into, of course, the details. The strapping tables. How accurate are the strapping charts for that tank? What are your maintenance procedures? How often do you have to do maintenance on that tank? How often do you have to pay attention to 2350? I'm sorry, 650, API 653. How important is API 2350 overfill prevention to you? And then there's the general location of the devices. So how important is that location of where those devices are installed? So even a spot temperature, for example, if you're reading a spot temperature in a tank, how much difference does it make if it's installed on the sunny versus the shady side of the vessel? How much will that impact your net volume calculations for that vessel? These are all very simple questions that typically have some easy answers, but they're all considerations that you need to have when you're making decisions on what types of devices to put at the tank. And I'll go back again to what about the devices you have now on the tank? Do you have a float and tape device already on the tank? Could you mount a transmitter to it and bring that electronically into the control room? Could you add temperature and pressure to it and do density calculations without having to do wholesale changes on your tank? And we have a chart that we use a lot to help our customers try to make those types of decisions. So the green, yellow, red backgrounds have to do with if it's on board or available or not, or if it is an option, or if it is something that is required or adds cost. The cost of these technologies from left to right starts with the lowest cost and goes to the highest in general. But there's decisions that need to be made here. Is custody transfer important to you? Do you need to be able to have official documentation coming from the field for for transfer of ownership of the volume that moves in or out of that vessel? If so, you'll have to go with something custody transfer capable. Do you just need general repeatability and level in the tank for accounting purposes internally? What about power requirements? There's only one of these below that operates and provides level information without power. These are just simple considerations to think about when you're trying to decide what is the best course of action for your facility. And then there's, other field devices. What about pumps, valves, pressures, flow rates, densities, proximity sensors, motion sensors, vibration, weight scales, presets? There are lots of devices out in the field to communicate with. And not all of those devices will communicate in the same way. So what interface devices will you need to facilitate communications to get all the data that you would like to have? And what type of signal do they provide? Do you just want a temperature to tell you I'm high temperature or I'm not? Or would you prefer to be given the actual temperature, in degrees, and then determine from it if you're high or not? That also gives you additional data that you can trend or use for analysis sake. Again, these are big picture items that impact the local on-site devices. Do the devices, do they use a proprietary protocol, or do they use an industry standard protocol? Because that affects the interface devices that you'll need in the middle. Do you need an RTU that can speak that specific device language? A lot of gauging transmitters use specific protocols because they share a lot of information, and industry standard protocols aren't always the most efficient way to do so. So what about these interface devices? Will a simple media converter work? A Modbus to HART converter, for example, or a Modbus to analog converter? Or do you need an RTU that is specifically designed to translate normal communication methods to specific protocols? Do you need something more robust like a PLC or an advanced RTU that can offer both discrete and analog and device-specific protocols all in one package to take advantage of more devices that are out there in the field or nearby the tank farm? And usually there's lots of options that you can available to you. It's a matter of picking the right ones to do the job, to allow this particular dot to contribute in the most effective and efficient way possible for the overall picture. Then you've always got the minor details you have to consider, especially with respect to the overall system. What do you need for automation purposes? What are the goals? Do you need to be able to track movements in and out of the facility? How often do you need those updates? Again, do you need them every few seconds? Do you need to calculate flow rates? Do you need to be notified when you're about to reach an alarm set point with high accuracy? Or do you just need the corporate office to get their update once an hour or every day or so? What about redundancy? Do you need redundancy for the field devices? Do you need redundancy all the way down to the tanks? Do you need redundant level indications? Or do you just need a level gauge and high-level switches for your redundancy? And then what type of security do you need around it all? Are you going to use a site network? Are you going to put it on a network that has exposure to the internet? Or are you going to put it on a dedicated network with then you got to get that data into the control room. So how do you get the data into the control room? Well, are you going to use wired or wireless? And wired or wireless always leads to the question of the simple initial cost versus the potential headaches long-term of wireless. You need to weigh those options and consider the pros and cons of each. Wireless sounds like a great initial solution, but wireless does also require power. So if you're going to put wireless out to the field, you're going to need power out at that tank or at that field device to receive that wireless signal. And if you have to run power, new wiring for power, you might as well run new wiring for communications while you're at it, and get the benefit of not having to worry about, relying solely upon a wireless signal for communications. Then what about the network you're going to use for communications? Are you going to use serial, keep it away from any type of internet protocol type of communications? Are you going to use internet communications, IP communications, but keep it on a controlled network and not put it on your business network? How is that data, once you get it in the control room, how is that data going to be distributed? Are you going to bring that data, all the data from a facility into one central point and share it out from there? Do you only need one central point to monitor that data? Or do you have multiple places to monitor the data? And if so, are you going to bring that data into each of those places individually and then share it between them? All these topologies are possible with modern systems. It's a matter of what you feel is the best and most efficient way to do it. A lot of times basing it on disaster recovery or redundancy. And then are you best utilizing the components you have, especially with respect to the components you already have or components that you need to complete the data chain? If you have an interface device out in the field, like an RTU or an advanced RTU or a PLC or something like that, are you taking advantage of the capabilities it gives you with surrounding devices to bring in enough information to really help the monitoring and control and maintenance even of the facility? Is the overall workflow easy to follow and understand? What do you use for an HMI? How do you expose this data to the operations? Do you use lights and switches or knobs? Or do you have a software application that presents this data to them? Does the workflow make sense to operations? Is it easy to understand? If you have a SCADA HMI solution, software application, how does that workflow? How many clicks does it take for the operator to do a certain sequence of operations? How much time do they spend switching screens in order to do their job? Simple questions like that. Does the software provide alarm? Lots of options out there today that can help you decide what the capabilities are and then help shape what's possible. And then how do you need to interface to other systems? Do you need to provide high-level indication to emergency systems or permissives? Do you need to receive emergency shutdown system notifications so that pumps or other systems can react accordingly? And then how much automation do you really want? Do you want to have your system protect itself from simple mistakes? For pump sequencing, for example, if you run a pump and then for a period of time and then stop it, do you want that pump to be able to start right back up again, or do you want to give it time to cool down before it's put back in operation? Do you want to protect the system by preventing a valve opening that would contaminate a line or a tank? Do you want the system to control the lineup entirely and just take care of lining up for appropriate product movements? These are all options in today's world. It's a matter of how much you want to move towards that automated capability versus letting operations manually go through each of the sequences and steps on their own. And then once you have all this information and you can monitor and control it all, then there's the aspect of what you do with it, how you monitor or handle transaction management, accounting, and back office reports and trends that come from this data. And for that portion, I'm going to turn it back over to Derek.
Thanks, Adam. So the first area that we're going to talk about interfacing to all of the systems that Adam's just talked about is at the load rack. Now, your facility may or may not have a load rack, but this is an example of an area that you may have not only your personnel interacting with the system, but you may have customers interacting with it as well. So one of the things to consider when looking at automating that load rack is, how are you going to bring the inventory information that Adam mentioned into this system and interface with it? You don't want a driver to show up at a load rack to load product and then find out that that product is not available. You don't want to land the legs on a tank or have some other problem during that loading process. So we need to think about, how do we make sure that the load rack automation is interfaced to the rest of that field and those devices? And then what interface will you use? What's the right solution at that load rack? Is it a manual operation today? Is it already automated in some way? What are the other systems that it has to talk to? Are you loading that product by volume or by weight? Do you have a weigh scale that you need to interface with? Are there weigh scales prior to getting on the load rack that you need to interface with and make sure that that transaction is collected in whole from start to finish? And then what about the operation at the load rack? How long will it take for a driver to get into the facility? How will they come into that facility? If the load rack is busy at that time, do you have a place for them to park? Maybe you need a preload station, something that a driver can come into the terminal, go to a preload station instead of holding up the load rack, and put in information about the load that they want to pick up and verify that they're authorized to load and that the product that they need is available. If your facility is not busy, then maybe the driver goes directly to the load rack. So those are some of the things to think about just from the operational side. And then what about the loading process and all the way from getting into the facility to getting the BOL? Are you going to automate that entire process? Is it going to be a manual process to get inside the facility? Is it a manual process to get the BOL? Does the driver need to exit the vehicle to do that? Or are you going to have a printing station for that driver to retrieve the paperwork? And then how will you manage and control that during unmanned hours? Is your facility unmanned, or do you want it to be unmanned? Maybe today it's not, but you want to look for an automation process that allows you to do that. Do you have the ability to validate company status? Do you have the ability to make sure that that driver and that vehicle is authorized to be in that terminal? Training records, inspection records for the tanker, insurance information. There are automation systems that allow you to put all of that information into the system. And if a driver shows up and is not qualified, maybe their training's expired or their driver's license has expired, maybe the insurance for the vendor company has expired or on that specific trailer, and those systems can deny access either to the terminal or to load product. Then we interfacing to third-party systems, PIDEX systems, optimizing the fuel cells, making sure that the customer from a third-party aspect has authorization to load. Integration with third-party systems like grounding systems, like a Scully system, maybe vapor recovery. Is there a dead man switch in place? Those types of third-party systems that you might want to interact with and engage with and have some control over back in that control room that Adam mentioned before. So that's some of the things at the load rack. Now, when we take all of the information that's been talked about so far, either from the tank, from the load rack, from the control room, there's going to be some back office aspect to this, where we're going to take all of that information and do some inventory accounting on that. We have to account for the product. We got to know what we have on hand versus what we should have on hand. And there are some standards that we have to think about when we're doing that. The requirements for reporting, and how are we going to implement all of the business needs, taking into account all of the data that we're receiving from the field. So do you have a manual process? Is there some part of that process that is manual? Maybe the load rack is not automated, and so you need to take paper tickets and you need to get those into the inventory accounting system. Perhaps you have bill of ladings on a receipt that you need to take and put into the back office accounting system. And how are you going to validate and make sure that that's quality data? Anytime you can put something in place where an operator can, as they enter the data, validate that information, you give yourself a better chance of having quality data on the back end when you get ready to do the inventory reconciliation process. How are those products receipts tracked? Are you doing some reconciliation against what came in on a bill of lading versus what you actually received? Is there an automated or a manual process in place to verify that that receipt that came either through a pipeline, a tanker, or a barge, that information on that bill of lading was accurate? And over time, are you looking at the reconciliation of that process? Can you automate that process? Is there some ability to collect that data electronically immediately and provide some reconciliation as quickly as possible? And then what about meter reconciliation? What about looking at the product that leaves the facility on a 24-hour basis and making sure that all of the individual transactions that left match up to what was on that 24-hour ticket to show how much product moved throughout the day? It's a very manually intensive process if you don't have automation in place, but it can be something that's very what the problem was instead of spending time just trying to get through the reconciliation process. And then some sort of calibration program to make sure that all of those devices that are measuring out in the field happens on a regular basis, because if you're relying on some of that automation, but your systems aren't calibrated, those things can also cause some issues. Once we have all of that part about the collection of the data and the processes by which we're doing the reconciliation, we also need to think about, now what are we doing once we are looking at those variances? Are we tracking those on a daily, a weekly, a monthly basis? I can tell you it's a lot easier to find issues if you're tracking your variances on a daily basis versus a weekly or a monthly basis. If you wait till the end of the month and you're working towards trying to figure out where you had problems in your variances, you're going to have a much more difficult time than if you're looking at that on a daily basis. And the more automated your system is, the more data you're getting into your system that's automated, the easier it is to do that on a daily basis instead of on a weekly or a monthly basis. And then once we go past that, we can also look at month-to-month trends. We can look at trends across certain tanks. We can look at trends across load racks. We can look at trends for pipelines, barges, however we're receiving that product. We can look at those trends as well to see, can we see patterns in our gains and losses? Again, that can be a very manual process if all of that data that comes into your system is manual and paper and somebody's having to enter that data. But if you have some of those processes automated, you can definitely make the ability to look across those much easier. And then just as important, how will you manage access to that data? The control and the security of that. We're going to talk about this a little bit when it comes to the enterprise data here in a minute, but who needs access to that information? Who should have access to change data? Who should have access to make modifications to and then how are you going to share that? Going to send out reports? Are those going to be automated? Are they electronic? Do you have to fax them? Do you have to email them? Maybe some of your customers want an export. Maybe it's a flat file, Excel file that gets sent out. Maybe there's a two-way interface where you send transactions off to someone and then they're going to send you the errors back electronically, and the systems are going to be able to manage that. Again, the more automated that process is, the quicker someone else can have that information, the quicker you can get the feedback, the quicker you can look for issues. And again, as I mentioned earlier, the faster you can get to correcting issues, the faster you can get to resolving problems, the easier it is. People are still available. Maybe the paperwork is still there to support it. You can go out and check information and you don't end up with problems that are lingering. So the key to that is how fast can we get that done? So then past the back office, let's talk a little bit about the enterprise. In today's world, more and more people want to take the information from a local site and get it back to a central location. Maybe that's because there are many facilities that they have across their network, and they want to bring all that information into one place so that the corporate level has some ability to see that data. Maybe they want to share that information out with the customer, and so they're bringing it up to that level. But how are we going to take that data and move it from that local site up to the enterprise, whether that be in the cloud or maybe that's in a system that's stored in a corporate office somewhere? But there's got to be some connectivity between those locations. And how often am I going to take that information off of that site? Am I going to do it once a day? Or am I going to do it after every transaction that occurs at the site? Or is it something in between there? Again, it comes down to the business needs. It comes down to how much do we need to have that data? How fast does that data need to get to that area so that we can share it with the people that need it? And then what data needs to be brought into the enterprise? Adam talked a lot about pump status on and off. He talked a lot about valve open and closed. Does that information need to make its way to the enterprise? Or does the business and the customer just need to see the end transaction? Do we just need to see what the total sales were? Do we need to have that information available for us there? So deciding what data needs to go and how often can be just as important. Then we need to think about what site data will be managed or controlled at the enterprise. Maybe the enterprise needs to be used to standardize the information across all of the sites. So perhaps you're managing your customers, your users, maybe the vehicles that arrive at that enterprise level, maybe recipes for the products that are being delivered is all managed at that enterprise level instead of being managed at the site level, which allows for standardization across all of those sites. Perhaps it's a modification versus a view-only capability. Perhaps you want users at the site to be able to make modifications, but you do not want users at the enterprise site to be able to do that. So you need to make some decisions about where will that control of that data be. Will the local site be able to add vehicles, but the enterprise is allowed to add companies, for example? So those types of decisions need to be made as you're going through creating those different levels and those different operations. And then another aspect to think about at the enterprise is, what type of group views do you need to see? Companies that might have more than a few sites maybe are separated by region. And so maybe they want to have regional views that roll up into a corporate view where someone can see all of it. Maybe you have customers that want to see that data, and so you want to create customer groups. And it's very likely that you want customers to see different information that you might want to see your regional managers or your corporate office see. So you've got to understand the role and the function of the folks that are accessing that data. What are they going to do with it? How are they going to interact with it? What information do you want them to be able to see and when? And then thinking about, again, like we talked about at the local site, how are we going to share that information? Are we going to share it in reports? Is it going to be an automated process? Are users going to be able to come to the enterprise and run reports? Again, exports and interfaces, those can be important to automate that process. Instead of having somebody come and pull a report, maybe sending that information out to them can be an advantage. Do you have a third-party system that you have to integrate with? Is there an ERP system, an SAP system that there needs to be an interface with that might be bidirectional, that can be more complicated, but can provide better validation across those systems? Is there a customer system that we need to send information out to? And what is that system? And what does that system expect? And what data is required to make sure that they have all of the information that they need? I talked about it a little bit before, but one of the really big questions when you start looking at an enterprise system is, will you allow customers to have access to that data? It's a big decision point, and it helps you to determine some of the architectural decisions that you'll make. Security standards, what type of data segregation you need to have, making sure that one customer can't see another customer's data. Those are all things that you need to consider when you start collating all of that information into one central location, is because now you've got a large piece of data that's very valuable. And of course, you want to make sure that only the people that should have access to it have access to it. So how you're going to manage that access, how you're going to control and secure that enterprise data becomes very important in that space. So as we've gone through that, we've talked a lot about connecting those dots, pulling all of that together, and making sure that you can get the data all the way from that tank, from that load rack, maybe from that field device, and get it back into a local accounting system. We're going to do some process on that to make sure that it's validated and all of the information is available for the people that needs to be there. And then we've talked about how to get that up into the enterprise and some of the that you need to think about on that side. So I think at that point, we're going to pause here for just a second. I think Margaret had mentioned in the chat that if you had questions, we can address those at this point. And if you have other questions, we can certainly take those here. So Margaret, do we have some questions for us?
Thank you. Yeah, thank you, Derek and Adam. Lots of useful information there. We do have a few questions from the audience. So Marie Claude has asked about powering wireless systems. So she says, are there any issues due to the environmental noise that need to be taken into account?
The short answer is yes. Anytime you're dealing with wireless, the wireless signal that you put through the air is competing with any other wireless in nearby frequencies that are also in the air. So anytime you're dealing with wireless, you want to have, I would recommend having an analysis done on using wireless in that particular location. Even things like line of sight or topology, a canyon wall, for example, can cause a bounce of wireless signals that can affect reliability of that communication signal. The amount of traffic nearby at typical international airports have lots of wireless traffic. In those cases, you want to get some specialized dishes or frequency antenna signals. Specific antennas, or you want to get registered for a specific frequency that's non-commercial use in those cases. there are considerations for wireless, but typically if you're out in the field and you're just out in a normal area and you have good line of sight and not a whole lot of metal for the signals to bounce off of, wireless is typically pretty reliable. Now, having said that, tank farms have a lot of metal. So if you're not putting the antennas above the tanks, then trying to send a wireless signal through a tank farm is typically difficult. So you're still running conduit for wireless antennas to the tops of tanks if you want wireless to each individual tank.
Okay, thank you. That's very helpful. So we've got another question. Do you integrate products made by other manufacturers or just those that Varec produces?
That's a very good question. So one of the things we've done very well at Varec over the years is to integrate with other solutions. We definitely take an approach of we want to understand the needs of the site, and if something is working and something would fit well into the topology, we often do not recommend that it's replaced. So yes, integrating with third-party systems, other devices is something that we've done very well throughout time, and it's made it easier on our customers to not have to replace everything all at one time.
Okay, thank you. Okay, we've got another question asking which is better, investing in multiple technologies and trying to integrate them or developing a customized engineered solution?
Adam, do you want to take that one?
I love the latter because I like engineering solutions from beginning to end, but honestly, the answer is it varies. And it varies a lot depending on what your goals for the system are versus what devices you already have in the field. So like Derek mentioned before, if you have devices that are sufficient for the job, we're not going to recommend you replace them as long as they're working reliably. We're going to try and find a way to get to the solution you want in the most cost-effective manner. I think that answers the question, I hope.
Okay, thank you. And another question, does Varec offer solutions for large and small operations?
Yes, we definitely do. We have done very small installations, one site type terminals, all the way through, excuse me, very large enterprise systems. Again, we take that approach of what does the customer need and what are their needs for growth. One of the things I tell our customers a lot of times is that sometimes people have started as small as with just some tank gauging information that they wanted to apply on their tank. And maybe it was even a local tank gauge that they had to walk out and see. But as their needs grow, they can come back to Varec and we can grow those systems with them over time. So because we look at the whole system and because we look at what are you doing now and what do you want to look at going towards the future, we can build out a plan that grows with you as your needs grow. So I think you'll find that, and we have a couple case studies I think that are attached here to the system. You'll see some of those are very large systems, but just because you don't have all the features and maybe you don't have all the systems that you see in some of those case studies, definitely let us know if you have questions, because we have solved the problems probably for more smaller sites than we have for some of the smaller, more complicated, because there are lots of small and medium-sized sites out there, many more than there are the very complicated sites. So short answer in that is yes, we've done very large and very small facility operations.
Okay, that's good to hear. Thank you. So before we wrap up, it might be quite nice just to look at the poll results. We asked the audience what their current challenges were, and the top results that have come in are communicating between systems, addressing cyber security requirements, and effective automation across facilities. Does this come as a surprise to you, or is this pretty much what you expected to hear?
No, those are the big three for sure. That's exactly what I would expect. Cybersecurity is growing and growing. The ability to have multiple systems integrated and working together, it's actually what we've kind of specialized on over the years, is pulling multiple systems together in order to bring them into one common operation. Those are exactly what I would expect.
Okay, that's good to hear. Yeah, we've got another question just come in. Salman asks, how about safety devices in the tank? For example, fire and gas detectors. Has Varec accommodated for those concerns as well?
So yes, we interface to those devices, and we can include those in automation and in your front-end HMI solution for alarm management and reaction. Yes, we absolutely have worked with those types of devices before. We don't offer those devices, but we, like we said before, we will interface to anyone's devices in order to meet the customer's needs.
Okay, all right. I think, let me just check if we've got any other questions. We can just go through a couple of the other poll results. So we asked whether companies were already exploring or have implemented cloud solutions for field devices. And the majority of people are saying that is the case. Again, is that where you'd expect it to be at this moment in time?
I think so, yes. We are just starting to see. Want me to go ahead, Adam? So we're just starting to see customers really get into that space. We've installed a couple of those systems here in the last year. I remember probably 10 years ago or so when the cloud really started taking off and people saying, can't ever imagine having some part of my control system managed through the cloud. And now we're actually seeing systems installed out there where folks are controlling their load rack, managing that process over the internet. Obviously, you have to have some of that infrastructure has to be in place for that. You have to have security things in place. But yes, we are starting to see that go. And we are actually doing implementations. We've done a couple already and doing another one right now where the system is being installed in the cloud. So we're definitely seeing a directive to move toward in that direction.
Okay, great, thank you. So we've got another question. How is Varec addressing overfill prevention?
So there's a variety of methods used for overfill prevention. In the U.S., we have API standard 2350, which is for overfill prevention. We help customers get compliant with that API requirement, and we're very familiar with it. So there are numerous methods to overfill prevention, from level switches, permissives on valves tied directly to high either software or hardware high level indications. There's a variety of things that we do, and typically we like to meet the customer's needs, but if we know they're going to do something that is non-industry standard or non-compliant, we definitely talk to them about it. But the customer typically drives how they would like the system to work. But if they want to ask us how we think the system should work, we can definitely offer that kind of information as well.
Okay, thank you. We do have a couple more minutes. I don't know if you wanted to run through some of the case studies that were on the screen, or if you prefer, we can send them around to everyone else afterwards.
So Adam, why don't you talk a little bit about the Delta farms on the tops of the trees there?
Sure. There are 3 tank farms at the Atlanta International Airport. Delta Airlines owns one of them, and we just completed an upgrade where we installed a new control system for them. We've got a long relationship with them, but it's mostly been from the HMI SCADA front end side, where we interface to their old control components. And earlier this year, we finished actually replacing their PLC and control cabinets, the old ones there on the left, the new one on the right. And we have a case study that you can download from our website that talks all about it. But the biggest system they had with their old system was that their pumps were always going down for maintenance. A big reason why is just the tank run topology, if you will. So the start order of the tanks was what they call a lead lag system, where they would start pump 1, then 2, then 3, then 4 as demand increased. And then they would shed back down to the lead pump. So they would get rid of pump 4, get rid of pump 3, and go back down. That led to like the 3rd or 4th pump being started and stopped a lot. And we replaced that topology with a first in, first out topology. so that we start pumps 1, 2, 3, 4, and as we shed pumps, we shed from the longest running pump. So we will turn off pump 1, then turn off pump 2, start pump 5, stop pump 3, etc. What it did is inherently led to long run times and long quiet times and a lot less pump maintenance. So they've been thrilled with the results. We first did that first in, first out topology at Chicago O'Hare back in 2004, and we've implemented a number of airports ever since. We've got another case study on this that you can download and read from our website. Here we actually integrated 2 individual PLC systems to function as one. So this addresses a question earlier on about getting multiple systems to coordinate together. This one was pretty complex in that we had to pass start and stop control between the 2 systems so that they would function as one and still run the pumps with the first in, first out topology. Like I said, we completed that back in 2004, and they just replaced the satellites this year, where we implemented the same topology at their main tank farm instead of the satellite farms. So we've got a long-standing relationship with Chicago O'Hare as well. And okay, we're addressing just the big complex ones here, but this is a facility that has 56 tanks, I believe. And you can see some of the graphics that we've made. We have, some of them are pretty complex looking, but it's their actual physical layout of the piping. So it's intuitive for the operators, believe it or not. When they look at the piping and the valve locations on the screens, they match what's physically out at the site.
Okay, excellent. Thank you. Oh, sorry. I was just going to say, just before we close, sorry to interrupt, we do have a couple more questions that have come in. I don't know if you want to take those quickly. Thank you. So we've got a question. Someone's asking, can the system help me to understand tank settlement problems?
Tank settlement problems. I'm not sure what settlement means. If settlement means settlement of sediment and water at the bottom of a tank, or if it means the tank settle period after a receipt to dissipate static electricity, or if it just means a new tank that needs to have the metal stretch and settle that will affect your strapping chart. The answer is we can help with all 3, but I'm just not sure which one they're asking there. So I guess the answer is yes. It would just...
That's good to hear. We can always ask the person to provide a bit more detail at a later date.
Sure.
And we've got another question asking if Varec is able to detect tank leakage sealing systems for floating roof tanks. So for fuel tank terminals, this is one of the most important issues.
Yeah, for open floating roof tanks, detecting seal leak issues would be monitoring the water levels in the tank. So you would need a water level sensor. It would be nice if you could combine that with simple weather data, so that if we know there's rain in the area, or if you have a rain gauge we can monitor, we can combine that with increases of water level in the tank, and we can let you know if you have a seal leak or not.
Okay, and we've got a couple of specific questions about locations. So someone's asking if they're able to get a terminal automation system in Uruguay, and someone else is asking if you have a local team in India.
Derek?
Yeah, the best way to handle those questions is to, send us an email. I put it in the chat, and I think Adam did in the questions as well. But send us an email to sales@varec.com, and we will either help you directly or we will get you in touch with a local representative in that area.
Perfect. Okay, well, thank you very much, both of you, for your presentation today and for comprehensively answering those questions. I think the audience have found that really useful. As I mentioned, everyone who registered will get the presentation emailed to them afterwards. And as Derek said, if you do have any further questions, feel free to email directly. Otherwise, thank you both very much.
Thank you, everyone, for attending. Thank you, Margaret. We appreciate it.
Thank you. Goodbye.
Yes, thank you. Goodbye, everyone.